Okay, so in my last video, I showed how you could find C of a mass function in order to create a joint probability mass function over a certain range. And we get this equation right here. But now we're going to use this equation to find the actual probabilities of specific points within this range right here. So, going right into that, using this equation up at the top, the first one we have is the probability of x equal to 1 while y is less than 4. And so what you do is the equation that you have, this is equal to the sum of r of x, 1 over 36, of x plus y. And r of x is basically all points where this range is relevant. So in order to kind of see what that is, I'm going to have x equal to 1, and then y is going to equal 1, 2, and 3. So that's the range right here. So you can actually look at this as the sum of x from 1 to 1 times the sum of 1 to 3, 1 over 36 of x plus y. So that's a way to kind of expand that out in case you're not familiar with this notation. But this is all points where this range is relevant, basically. So then, going through this, it's actually fairly easy. All you got to do is, let me get my notes up here to make sure. I don't want to make a mistake and mess you guys up anywhere. So you can expand this out as function 1 over 36 of 1 plus 1 plus 1 over 36 of 1 plus 2 plus 1 over 36 of 1 plus 3. Got that right? Okay, yep. So you can basically factor out the 1 over 36. So this is equal to 1 over 36 of 2 plus 3 plus 4. And this is 2, 5, 9. 9 over 36 is equal to 1/4. And that is the probability that you have x equal to 1 and some y less than 4. Right there. Okay, so now if you have the probability of x equal to 1 now, well, if you look at the range that we have, x equal to 1, well, that's basically what we just had before, because since we don't have any more points in y, there's going to be no change between these, because we still have x equal to 1 and then y equal to 1, 2, 3 for all points where x is equal to 1. So this is also going to equal 1/4. I mean, if you wanted to expand it out, you just end up with this again. So basically x and all of y, which is what we did with this last one. And then you have probability of y equal to 2. This one's a little bit different, but again, sum of all points where y is equal to 2. So in this case, we're going to have y and all the combinations of 2 that go with x. Combination rx, now ry is equal to 1 over 36 of x plus y. So we're going to have 1 over 36 of 1 plus 2 plus 2 plus 2 plus 3 plus 2. So we keep y constant the whole time and then fluctuate it through all the combinations of x that it can have, all the different partners with x it can have. So working this out is 1 over 36 of 3 plus 4 plus 5, which is 9, 11, or no, 12, 9, 12, which is then equal to 1/3. And that is the probability of y equal to 2, where you have all the other x's along with it. So when you're working with two random variables in a discrete system like this, if you have just one variable given, then you immediately partner it with all the other ones, all the other opposite variables, partner variables, that this could possibly go with. So we've got the range of x, 1, 2, 3, and y equal to 1, 2, 3. Each one of these is combined with the other series set of numbers in order to create a full distribution. That's a little ambiguous, but you can see how it's working right here. So if y is equal to 3, match it with every x that's available. So that's how you get probabilities with discrete random variables.